Welcome to the PlanetTogether Life Sciences Solution Demo. Advanced Planning and Scheduling, or APS, is a planning process by which raw materials and production capacity are optimally allocated to meet demand. PlanetTogether is an APS solution that simultaneously manages constraints for available materials, labor, machine capacity, and sequence-dependent setup. This results in optimized, feasible production plans and schedules, created in seconds or minutes for large models. In this model, we're going to take a look at a plant in the category of life sciences and how PlanetTogether can be used to schedule production, taking into consideration constraints and compliance issues. The use cases we'll be walking through today include tank scheduling, where we will show routing options using multiple tanks. We'll also model plumbing constraints that limit the downstream resources based on the selected tank. Next is shelf life constraints, where we see that material in a tank is no longer available for production once the shelf life has been exceeded. And lastly, we'll look at lot control, where we'll see a raw material lot received on a purchase order, consumed by a job, and produced for a sales order. In the first use case, we'll look at modeling tanks. In the tanks department, we see a few tank resources and a pack line. The first job scheduled on tank A is tank job 1. On the Gantt label, we see a green section indicating the processing time, where the tank is being filled or material is being mixed. The yellow portion of the label indicates where material is either being stored or being emptied from the tank. On tank B, we see tank job 2 is emptying material from tank job 1. On the tank's pack line resource, we see two pack jobs. The first is pack job 3. It consumes material from tank job 2, which in turn consumes from tank job 1. These two tank jobs are independent of each other. Nothing is preventing tank job 2 from receiving material from another tank job altogether. This is useful if you have multiple tanks producing the same material with no preference on which tank is emptied first. The second pack job 5, is fed by a single job, tank job 4, which models both tanks as individual operations within this job. This constrains the second tank to only be able to pull material from the first tank scheduled in the route. This can be used when material traceability is necessary, so we can be sure which job is going to use the material in the tank. In the next use case, we'll look at modeling plumbing constraints. In this example, machine 1 can only be fed by tank 1, and machine 2 can be fed by either tank 2 or tank 3, but not tank 1. In this department, we see the 3 tanks and 2 machines. There is a single job, job 20, with 2 operations. We have defined 3 paths or routes that apply the constraint. They are path A, path B, and path C. The job is currently scheduled on path C, which shows machine 2 being fed by tank 3. We can use the Alt drag and drop method to switch between paths. Let's give it a try and review the constraints. If I move the first operation to inline tank 1, we see that my downstream job is only eligible for machine 1. If I move to tank 2, we see that my downstream operation is only eligible for machine 2. But if I move back to tank 3, we see that my downstream operation is once again only eligible for machine 2. In the next model, we'll show shelf life constraints. In this use case, we'll see what happens if we don't consume all the material from a tank in a timely fashion. We've constrained the model in a way that prevents expired material from being used in production. We do this by using the shelf life property. By setting this to 1,000 hours, we cause any material remaining in the tank after this duration to become unavailable. In this department, we have a job, shelf job 1, scheduled on the tank resource. There are 2 jobs in the pack line resource that consume the entire contents of the tank. The tank fills and empties without reaching the shelf life expiration date. The next job scheduled on the tank resource is shelf job 4. It fills the tank, but only 1 job on the packing line consumes from it, and it only partially consumes the tank's contents. We see the green section of the Gantt label indicating processing time, and the yellow section, where the material is able to be emptied. Since no other jobs are scheduled to consume the tank's material during the 1,000-hour shelf life period, we see the tank empty. This is indicated on the Gantt, where we see the job end and no longer take up capacity on the resource. This feature is used to prevent expired material from being used to fulfill demand. In our next use case, we will model lot control. In this use case, we'll trace lots through production. We'll purchase a specific lot, which we'll then use in production and produce separate WIP and finished good lots. Finally, a sales order will consume the finished good lot. This can be used to meet requirements like limiting a job to only using material from specific locations. Let's first look at the purchase orders board. Here we see the item LC01 raw is being purchased in a lot of 5. The lot number is AAA, and it's due to arrive on the 19th. Now let's look on the Gantt in Department 1, where we see a job called Lot Job 1 with 2 operations. The first operation consumes the purchased raw material with lot number AAA. Since that specific lot doesn't arrive until September 19th, this operation won't start until its arrival. The operation then produces an inventoried WIP item with lot code WIP lot AAB. The second operation consumes the WIP lot and produces the final product with lot number FG lot AAC. Now let's take a look at the sales order board. We see that we have an order on the books wanting to consume 4 of the 5 units from FG lot AAC. This completes the process of controlling the lots used from purchase through manufacturing and then to sales. This concludes our life sciences demo. Thank you.